Today we're going to talk about electrolysis cells. Electrolysis cells are not the same thing as an electrochemical cell. In an electrolysis cell, you actually have to put energy in order to drive the chemical reaction, as opposed to manipulating a chemical reaction that has a spontaneous reaction. Electrolysis cells take electrical energy and they drive electrons through a circuit. Electrical energy is needed because the electrolysis reaction is not spontaneous. When we calculate potential voltage, we can always identify an electrolysis reaction because it is a negative voltage. This is in contrast to electrochemical cells, which have a positive voltage and spontaneous chemical reactions. One of the most famous electrolysis reactions is that of molten sodium chloride. Sodium chloride is salt. The salt that you put on your food, for example. In the electrolysis of molten sodium chloride, what we are trying to do is split apart sodium chloride into an atomic form of sodium and chlorine gas. Because we're splitting up the sodium chloride, the word lysis is used. Lysis literally means to split. Electro comes from the word providing electricity. Please assign oxidation numbers to all of the substances in that chemical reaction.
No.
What are you doing? Oh my god. Stop writing on my stuff, Connor.
I don't believe
You already do.
Gentlemen.
you know what those NaCl was,
You already looked at the thing.
NA is in the first row of the column. First row is always plus one. So each has plus one.
Chlorine
Plus one.
has an oxidation number of 0. Sodium has an oxidation number of 0. Chloride has an oxidation number of -1. Sodium has an oxidation number of +1. There we go. If Cl-1 starts off and then goes to Cl2, has it been oxidized or reduced?
Reduce. Oxidize. I always get that mixed
If it goes from +1 to 0, it has been reduced. Based on that, we can then identify what is the oxidation part of the chemical reaction and what is the reduction part of the chemical reaction.
This has a really big charge.
Sodium has to gain 1 electron in order to become the sodium ion gains 1 electron to become sodium. Okay, so
This is
the
zero.
chlorine has to lose 2 electrons.
CO2.
The number of atoms are not balanced because we see that chlorine has 2 parts chlorine on the right hand side, which means you need 2 chloride ions to lose 2 electrons in order to form the diatomic molecule of chlorine. Potential voltages for each can be taken from your data booklet table. We're still using the same reduction reaction table as we have for the past 3 or 4 classes. What we should see when we add the 2 half reactions together is that we have an overall negative voltage. I just want to go back to this reaction up here for a moment. We saw that this substance was going from positive 1 to 0 and it was being reduced. Is Na positive, the reducing agent, or is it the oxidizing agent?
It's the oxidizing agent.
It is oxidizing agent. Versus chlorine is going from -1 to 0. It's oxidation,
So it's reducing agent.
which means that Cl negative is the reducing agent. So what I want you to do is find Na positive and Cl negative on your data table. Find these 2 half reactions. Positive is on the right hand side. Okay, did you find it?
No. I didn't found any. Oh.
That's Cl right there.
Oh, and here's the Na.
Okay, and then A. So which one is higher?
2CO.
Definitely Cl. So the oxidization reaction's higher.
Okay, so in this case, Cl negative, which is the reducing agent, is higher than the oxidizing agent. Remember we talked about the positioning of OAs and RAs yesterday?
Mm-hmm.
If OA is above RA, it is spontaneous. However, if the RA is above the OA, it is not a spontaneous chemical reaction. Squished a little bit here. Just here we go. All right. So we have the reaction of sodium chloride going to sodium and chlorine gas.
Miss Patterson, what was this?
It's oxidation,
Yeah.
which means you're losing 2 electrons. You need 2 electrons on the
Where did
side.
we jump to?
Is that next page? Is that right though?
Should it be Cl negative on that side too?
It's right there. Cl negative is on the left-hand side because if you take your original equation, which is going to be NaCl to Na plus Cl2, NaCl is actually Na positive, Cl negative together in an ionic compound. And what you're trying to do here is isolate the reduction reaction and then isolate the oxidation.
So wouldn't you have to flip those though?
No. You don't do any kind of flipping. This is the equation that's given to you. If it was asking you to come up with an electrochemical cell, then yes, you would choose the reaction.
Then it would be Cl2 to Cl negative plus 2 electrons. If you were asked to create the cell.
I was asking for an electrochemical cell, but we're discussing
Yeah, no, I just wanted to make sure that I was.
Yeah.
So because we're discussing, we're not discussing electrochemical, we don't have to flip the I can't oxidate, whatever reaction.
Just for right now, I've given you what the chemical reaction is. There is no flipping. Okay. We'll learn how to write the equations if the problem is given to us. So, if we have molten, which just means melted sodium chloride, going to the right-hand side of this equation to form solid sodium and chlorine gas, it is a non-spontaneous chemical reaction, which means I have to push the electrons. I push the electrons by adding a battery to the circuit. Versus, if I were to flip this around and react sodium and chlorine gas together, it would be a spontaneous chemical reaction, which is an electrochemical cell. If we use liquid sodium chloride, we have to use an inert carbon electrode. Why do you think we have to do that? Oh, do you have your mobile technology?
Yeah.
Can you please look up the melting point of salt?
Isn't it like 300 and something degrees? Isn't it really hot?
What temperature does salt go from a solid to a liquid state?
Talking about sodium chloride.
What temperature?
801 degrees Celsius.
Pardon me?
801 degrees Celsius.
It has a strong electrostatic
So,
attraction between its positive
If
and
we
negative
put
ions.
in a sodium electrode into this, well, what is the melting point of solid sodium?
Low.
What's going to happen if we try to put a sodium electrode into something that has to be a minimum of 801 degrees Celsius?
It's gonna it's gonna be gone.
It'll be gone. Right? What about, okay, let's use a solid chlorine electrode. What could be the problem with that?
Doesn't it have to be really cold to be solid?
Very cold. At room temperature, chlorine gas is a gas. It's not solid. So if you have something that's 801 degrees Celsius, there's no way you can put a chlorine solid electrode in there.
Well, you could. It's just as soon as you put it in there,
It's gone and you don't have a cell anymore. You don't need an anode and a cathode for this to happen. So we cannot use a sodium electrode. We cannot use a chlorine electrode. We use what's called an inert carbon electrode. Carbon allows electrons to pass through it, but it doesn't alter the chemical reaction. We also must need a battery. It also must have a battery. It used to be a common exam question where they would give you a picture and ask you if it was an electrochemical or an electrolytic cell.
Oh, you have to look for the battery.
Exactly.
Very smart thinking.
Exactly. That's what you've always looked for.
You said that if you just said it.
Super smart ability.
If you just said it.
So much smartness as well.
So you would have something that looks like this.
Yes.
Everywhere.
What you notice is the same or different about the electrolytic cell compared to the electrochemical cell.
They're not connected by wires in this picture?
Yes, we still have wires.
There's no salt bridge.
The wires go from here
Oh.
to here, here to here.
I was wondering how that worked. I see it.
Pardon?
There's no salt bridge
No salt bridge. Why?
because it technically isn't it acting like a salt bridge?
Both the electrodes are in one cup.
Because we have salt in there already.
You don't need a salt.
very smart.
Okay.
What did she say?
She said because it's only one.
You also only have how many containers here?
One.
Just one container.
Yeah.
You don't need to have a cup within a cup or a cup for the oxidation half cell and a cup for the reaction half cell.
Because you don't have a salt bridge and you just have Na, you just have salt. Will that salt disperse or will it stay?
As long as it is hot enough, it's in a liquid state.
So then it just stays.
Eventually, as it is used up, you are going to get a gas. So you have to have some way of collecting this gas. What do you know about chlorine gas?
It's known as mustard gas.
Mustard gas.
It's extremely deadly.
This is not something that I suggest you run in your shops at home.
Toilet bowl cleaner and what is it?
You will have the sodium plate on one of those electrodes, and you can actually scrape off the sodium that is formed and use that sodium for scientific experiments. You have
We should do
battery.
First sodium goes boom in water.
Kill the fish.
Another difference is right here.
Go boom. Okay.
You see what is different about those two sections that I just circled compared to the electrochemical cell?
The anode is positive and the cathode is negative.
In an electrochemical cell, the anode is the negative post and the cathode is the positive post. In an electrolytic cell, the cathode is the negative post, the anode is the positive post. Why?
Because the electrochemical cell is basically it's like going backwards. It's like because it's non-spontaneous, going backwards and almost recharging. So it would be negative on that side, positive on that side because it's recharging.
That's a good way to think of it. That is a really good way to think of it.
Electrochemical.
The
anode
other
is
way to think of
negative.
it is to look at what terminal it needs to hook up to the battery. If this is your source of electrons are going to be attracted to the positive side of the battery. And then over here, this is going to push the electrons down this so that the sodium ions in the liquid will be able to gain those electrons and claim as sodium.
Yeah, 'cause cathode's-
Now what's really neat is that
It's negative.
this here is an electrolytic cell,
Wait, this is
but
electrochemical.
this up here is the battery. And this is an electrochemical cell.
So the cathode post is getting plated by the sodium. Okay.
If you decide you want to get into the business of chroming bumpers for people, make your fortune off that way. You need to make sure that the rescue bumper is the cathode.
Okay.
That's where the plating is going to happen.
So the plating always happens on the cathode?
Yes.
Okay.
So the electrons travel from the negative terminal of the battery down to the cathode here. The sodium gains electrons and starts collecting on the side of that electrode. Over here, the negative ions go towards here, and then they go through oxidation, and then they lose the electrons. The electrons travel from this post to the positive side of the battery. Again, what's formed is a chlorine gas, so you need to make sure that you take steps to actually protect somebody who is doing this experiment. One condition which is really important is that you must make sure when you do electrolytic cells that the reducing agent you choose is higher on your table than an oxidizing agent. Do you have gray or silver colored keys today?
In my jacket,
Oh, good.
but not on me.
Awesome. Let me do some later.
Do you guys need them? Just kidding.
We're not going to play with silver.
Darn it.
Can I go
I
grab
know
my
my
keys?
budget just does not allow for that. We're going to play with copper.
Can I go grab my keys?
Can we play with brass?
Yes. I'll be back.
Pardon me?
We do with brass?
We can try playing with brass and see if it sticks. I mainly experimented with these type of keys.
Will I be able to take this home after class today?
Absolutely.
Okay.
Will it still start my vehicle?
Yes, it will.
Will it still go into the gym lock?
You might wonder why it's brown instead of silver.
Now,
That's
do you have a chip in your key?
Pardon?
Do you have a chip in your key?
I do.
Then
No,
you should
don't use
that
your
one.
car key then.
I know.
Are you running electricity through it?
Yeah, don't use this one.
You
Use
shouldn't.
this one.
You shouldn't. cut
No,
it.
this one's my gym key.
So what I do is I use a house key, for example, in order to put it.
Oh.
So I'm going to show you electroplating using this example, and then I'll give you directions on how to do the copper plating. But it's basically the same idea.
Wait, can we do, like, is there colored metal? I wanna
So-
plate my key blue.
You still need an electrolytic solution.
Really?
Do you remember what an electrolytic solution is? You got your keys? Excellent. An electrolytic solution conducts
Electricity.
electricity. We need a solution that is going to have the ions of the plating metal. If we're going to coat your keys with copper, then what kind of solution are we going to need?
Probably copper sulfate?
We can use copper sulfate because it's soluble. Absolutely. And that's what we're actually going to use because I don't have very much copper to nitrate now.
Yes, that's what I guessed. Alright, Connor's number one.
No.
And I would say for the purposes of this lab, probably half a scoop in about 50 milliliters of distilled water will give you a good enough source of copper ions to coat your key. We need a source of current.
Batteries.
I'll get into the wall.
We're just going to use a 1.5 volt battery.
Can I plug it into the wall?
No. And not the wall.
What would happen if we plugged it into the wall?
No, we're not going to go there.
What would happen?
If you plug it into the wall and try to electroplate it, chances are you're going to be calling an ambulance and feeling a lot of pain.
Can we
Let's
try
do
it?
No, you may not, because I really don't want to do a pig
I have a question. Can we plug it into a power bar?
Onward, because that's so different. Let's plug
Okay.
into an extension cord.
Hey, who said it?
She
Not
did.
me.
She said not the wall.
Can we plug it into a laptop?
Lovely, and this lecture is being recorded. We need 2 electrodes. One electrode is going to be your key.
Somebody wanna get my key?
Here.
The key is going to be the cathode, which is not the positive host anymore. It is the negative host, which means when you connect it, you need to make sure that key is connected to the positive side of the battery. Then we'll have the other part of the wire going down. The second electrode needs to be what you're plating with. No, we're not going to plate your copper.
Why not?
Because it's aluminum, not metal.
Onward.
Can I say it's aluminum and it won't work? Because aluminum doesn't connect electricity.
It conducts very, very poorly.
So it would
Way to
take a
go.
while then.
What about your coffee cup?
When aluminum is exposed to the air, it generally forms a protective coating on the surface. It makes it very hard to electroplate. So I would not suggest trying to electroplate aluminum. What are we trying to plate the key with?
Copper.
Which means that you must have
Copper ions.
copper strip. for the
Copper
center of
strips.
the other electrode, which is going to be the anode. The anode is going to be positive. Make sure that connects to the negative terminal battery.
Is there a way that we can make it so like I dye my key with something and the metal that gets plated on is blue?
Can you just put blue dye in there?
No.
That
I don't
is
know.
likely to be some kind of a paint rather than metal.
So that like I can't plate my thing with like a color?
No.
Copper is a color.
So is brown.
Copper is a description for a color, yes. We're going to hook this up and plate some keys.